Back to YouTube channel Naren_ here. We were going through section 2.1 of chapter 2 linear functions, and the section was introduction to linear functions. We will continue from where we left off. We completed number 1, and now we will start from problem number 2. Now we have few problems here that we will solve. First we will solve problem number A. The solution to this problem is, so find the equation of a line that satisfies the followings. So what are we given? We are given slope, which is denoted by m, which is 7, and y-intercept. Y-intercept is denoted by c. Sometimes it may be represented by in this form also 0, 2, where x value is 0 and y value is 2. So this is another way of representing y-intercept. Now we will just since this is the slope intercept form, m and c, we plug these values into that equation, mx plus c. So y equals 7x plus 2. So this is the equation of a straight line that satisfies number A. Similarly, number B is exactly similar. There is nothing difference. It's just that the y-intercept is given in the point form. I recommend you to do this number B. Number C, let's do number C. It's slightly different. Let's try to solve number C. So what is number C? Number C, first of all, write the given things using notation. So this is slope m equals 5. Now recall that y equals to mx plus c is the equation formula. So we know m, but we do not know c. So somehow, if we know but we have this extra information, if we can use this information to find c, then we are done. So we will use this information to find c. So this also can be represented as f of x. So we will use these values over here. So we know m. So what is f of x? F of x is mx plus c, and we are given value that f of 2 is -3. So let's find f of 2 from here. F of 2 equals m -5 times x is 2 here and plus c. But f of 2 from given is -3 equals -10 plus c. So we add 10 on both sides, and we get value of c to be 7. So since the value of c is 7, our required equation becomes required equation takes the form -5x, y equals -5x plus 7. So this is our equation. So this formula we use when we do not know c directly, which is y-intercept. So these were few types of problem. Next we will plot a graph of a straight line. How to plot a graph of straight line? So let's do number A first. So y-intercept and the slope is given. So since y-intercept is given, y-intercept is always can be written in the form of point, which can be written as 2. So this is one of the point. Since we are graphing a line, 2 points are sufficient to plot a line. To graph a line, 2 points are sufficient. So we already know 1 point, and we require one more point to draw this graph. Now what else do we know? We know the slope. We know slope, and slope is always given by rise over run, correct? Rise over run equals -3 over 5. So from here, to draw the graphs, we know one of the point, and if we can find another point, we are done. But let's use this slope to find rise over run. So what does this imply? This implies you can assume that rise is -3 and run is +5. You can change, you can also choose these values the other way around. If you choose this to be +3, you have to choose this to be -5. The final point you're gonna obtain from this rise over run is the same. So once you find this point, so locate 0, 2, 0, 2. So for example, let's move this a little bit downwards. So locate 0, 2. Where is 0, 2? It should be somewhere here, 0, 2, right? And now rise. What is rise? Rise is along, let me clarify something. So slope is always, the top is always y-axis and bottom is always x-axis. So y-axis and x-axis. So this is rise, this is run. So positive along vertical axis means up or down, whereas along x-axis plus or minus means left or right. So plus means right, right and left, right, left. So once we locate 0, 2, so what is our rise? Rise is along y-axis. Y-axis means it is -3, so 3 units down. So what is 3 unit down? So this is 2 unit, this is go 1 unit down. So this is 2 unit and this is go 1 unit. So what should be this point? This point should be 0, -1, correct? But this is only rise. Now run is along x-axis. So 1, 2, 3, 4, 5, right? So this is how much? X-axis, along x-axis. So 5, -1. So these are 2 points. So these are the 2 points, point number 1 and 2. So these are the 2 points that lie on this line. So now what do we do is we connect these 2 points, and that is our straight line. This is the graph of figure A. So this is a graph of this line with intercept 2 and slope -3/5. Similarly, we can draw this number B. I strongly recommend to practice this problem number B. Now we'll move towards some application problems. We'll solve few application problems, and I want you to pause this video and go through the instructions. I hope you have paused the video and read all instructions carefully. So first of all, before going through these application problems, I want to recall few things. Mx plus c. So these are this is the equation of a slope intercept form, where m is the slope, rate of change, how something is changing with respect to x, how something is changing with respect to x, and this is some fixed value, which is initial value, also called some initial value or fixed value, initial or fixed value. Okay, so now let's do this problem. So what is the fixed value here in this case, and what is the rate? So rate, what is rate? Rate is m equals $72 per pound, and what is a fixed price? So fixed cost, which is lowercase c, equals $5. This is $5. Now what they are telling us, if c represents a number of pounds per package, and c is the total cost of shipping, so total cost of shipping, write the linear equation there. So there are two ways of doing it. First, let's discuss alternative way. So here, what is the price, cost of 1 pound? package, cost of 1 pound of package. So this will be $5 is fixed, right? $5 is fixed plus, or you can go the other way around. It's so if this is 1 pound, so this 0.72 plus $5, correct? And what will be the cost of 2 pound package? It will be, this is the rate and the price is fixed. Similarly, 3 pound package will be 72 times 3 plus 5. So this will be the total cost when it is 1 pound, when it is 2 pound, and when it is 3 pound. So what if there are p pounds? So cost of p pound of package equals to 0.7 times p plus 5. This will be the total cost. So this is represented by 0.72 p plus 5. So this is the alternative method, but since we are doing application to this problem, we will use the linear equation. So here let me recall few things again. M is the rate of change of y with respect to x. Y is some quantity, whatever you are studying. Y is the quantity that you are studying, whose rate of change you are studying. M is the rate of change of that quantity with respect to x. With respect to what? With respect to, it could be anything. For example, with respect to time, or with respect to weight, or with respect to distance, whatever. And c is the some fixed value. So what is the rate here? Rate is M, fixed price is c, and what are you studying here? What are we modeling here? We are modeling, if p represents the number of pounds per package, so we are modeling pounds per package, and c is the total cost of shipping. So write the linear equation that represent relationship between c. So we are trying to model here total cost, and we are studying with respect to, it is changing with respect to p, right? Whenever you will have more pounds, total cost will be more. When you will have less pounds, or less number of packages, or less weight of the package, you will have less cost. So c is lowercase. So this is how we can model, right? So y equals to mx plus c. Can we make connections? We're modeling y, which is in this case c, where the rate of change is m, nothing different, and we are studying with respect to the number of pounds. C is some fixed value, c is some fixed value. So what is c? C is now 0.72 pounds plus, what is this? This is $5. So this is the same equation, and this is the same equation. So this is how we solve one of the application problem. Similarly, we have another problem here. Now I will not use this this technique. We can use directly use this technique. So please pause the video and try to do it by yourself. Okay, welcome back. I hope you have gone through the instructions, and now let's try to solve the so first of all, what are we modeling here? What are we modeling? So this is rates are $60 per hour. So this is the rate, definitely, and the base price. This is base price means fixed price. So rate is $60, and base price is small c, which is a fixed amount. This is $290. And what are we modeling here? If c represents the total cost and the h represents number of hours, so the total cost depends upon number of hours, right? The total cost depends upon number of hours. So we are trying to model total cost with respect to number of hours. So c equals, the formula becomes, so y equals to mx plus c is the standard slope intercept form. What is rate here? Rate is m, and c is the fixed value. What are we modeling here? We are modeling c, capital C, and with respect to what? Number of hours. So this will be the form, right? So what is m? M is 60, h plus 290. So this will be the model equation written directly. So these were the few application problems. We are done with section 2.1 here. Next time we will go through section 2.2. and the section 2.2 is linear expressions. Linear expressions. So until then, keep supporting, and do not forget to like this channel, like and subscribe this video, like this channel and subscribe this. So like this. Sorry, I'm tongue is slipped. Like this video and subscribe my channel. Do not forget to press the bell icon.